All right, let's get started with the November 2023 OpenZFS leadership meeting. I didn't see too much on the agenda. One piece of news, we have the videos from the OpenZFS Dev Summit. I'll post it on the YouTube channel and they're linked on the website. I'll send out an email later today to folks on the mailing list. But I also wanted to give a huge thank you to Michael Dexter for editing the videos and getting them all posted and ready and combined from all the multiple sources we had to use to get the video and audio and everything. So thanks so much, Michael.
You're welcome. And I'm willing to further polish up videos for individuals, but there was a whole lot of cleanup to do to get to what we achieved.
Alan, you should be particularly thankful because apparently he fixed your voice for your talk.
Oh, you were able to fix
Alan and the Chipmunks, yes.
the 44.1 versus 48 kilohertz thing. I didn't know that was like possible. So thank you.
Matt also suffered that, but fortunately it was a solid like 10 points off, so I just banged it down.
Okay.
Anyway, enjoy.
Thanks. All right. What agenda items do folks have?
Is George here? I'd love to find out more about the concurrent pool import stuff he was working on at the hackathon.
I don't see him. I know he has been working on it among a bunch of other stuff he's doing, but I haven't heard, he hasn't mentioned any specific progress to me.
Okay. I'll keep pinging him on Slack. He sent an update last week that it sounded like it was in pretty good shape.
Cool.
We had stuff on an outstanding pull request for Zed to automatically degrade VDEVs if they've had too many slow IOs, to try to, especially in a RAID Z, one disk having slow IOs because the hardware is on its way out, can drag down the entire VDEV or the entire pool and really tank your performance. And so being able to degrade that and possibly replace it with a spare, or even just be able to trigger offlining it so that the performance of the pool goes back to mostly normal is interesting. There's been a little bit of feedback, but if other people are interested, we'd love more input on that. I pull up the PR number here.
I wonder whether we already have mechanism to make sure that we never disable more than one VDEV at a time to not lose critical mass. Having 5 slow devices, yes, betas and don't have pool at all.
Yes, the changes Don did will not degrade a second VDEV if the Z case on one VDEV has not been solved yet. So it's specifically to the point you brought up, I think 2 months ago, won't degrade more than one VDEV at a time. So that, yeah, if you have like a JBOD or a cabling issue or something that makes a whole bunch of drives slow, it won't try to knock your pool over or anything terrible. So it's pull request 15469. I'll put a link to that in the notes or whatever. And it, similar to what we did previously, it adds the VDEV properties to allow you to control how many slow IOs and what period of time is when it should react.
Does it have to be positively set? Is it sort of off by default?
I think yes, based on feedback from Tony Hutter, that they see enough slow IOs that they wouldn't want this behavior going off unintentionally.
Right.
But yeah, like even saw a case 2 weeks ago where one disk randomly having to do a bunch of retries to read a failing sector or whatever was, or a drive that was having really high latency dragged to pull down from doing, a gigabyte a second to doing 60 megabytes a second, and that really impacted the workload. And as soon as I zpool offline that one disk, everything was happy again. And being able to kind of automate that, but as Alexander said, only if it's just one drive doing it, I think can make a really big difference to a lot of people.
Sorry, I muted. Speaking about retries, that reminded me of flag we have, at least on Linux, supported for fail fast or something like that. It would be good to review that ZFS properly sets it in reasonable cases. Like if we have mirror, we could set it then when we try first component, but try it deeply on we have another same time. Don't fail fast if we have only one disk without redundancy. We're doing something like that, I think, when we're doing a retrial after the first error, but maybe it could be made deeper, better.
Yeah, I think there's a bunch of places where we should inspect how we're using fail fast, or places where we're not using it, and we probably should be.
All right, other topics for today?
Another one we've seen in the field on, I think, 2.15 or so, and I'm wondering if maybe it's already fixed. Application has mmap some data. Then they do a ZFS rollback to revert to an older snapshot. And if you continue reading from mmap, it's still the not rolled back version of the data. And they found they had to unmount and remount the file system in between to make sure mmap was correct. Is that something that maybe has already been fixed? I know there were some changes to mmap, but I haven't had a chance to read through all the changes yet. This is on Linux specifically.
I haven't looked at any recent changes there, but that doesn't surprise me too much, that bug. The way that like the interlock between, like, so there's the mapped data and then like what's in ZFS, and they're not integrated.
Mm-hmm.
So the way that it's normally resolved is like when you have a read or write, it'll check or update what's in the page cache. But in this case, like you don't have a read or a write.
Right, it's happening with covers.
Yeah. So, probably we need to add some code that would like evict stuff from the page cache, or go go say like, hey, everything in the page cache needs to be refreshed after you do a online rollback.
Right, and validate it.
Yeah. Which, that if you're not using mmap extensively, then that would be no big deal. If you are using it extensively, that might impact performance. It might take some time to do that.
Yeah, this is a many terabyte SQLite database.
Yeah, but it depends on how much is mmapped. Like if the whole if the whole thing's mmapped, and it's all like in if you have like a terabyte of RAM and it's all pages that were read from your files, and then you do a rollback, well, I mean, SQLite is not going to be happy. I'm guessing. If you're changing the data out from under it, but it would be correct at least to have it see the new data after the rollback.
Yeah, I think correctness trumps performance there.
Yeah.
Yep.
I mean, in terms of getting to correctness easily, you could just say like, hey, if there are mmap pages, then this rollback cannot be done online, and we're gonna unmount and then remount your file system, or fail it and tell you to do that, or something like that.
Yeah, that maybe is safer. Go ahead, Mark.
Can you tell? I mean, what is the online rollback managed through? How is that performed? Is that an octal pool or CFS command?
Yeah, ZFS rollback ioctal.
Yeah. All right. Yeah. So you have to be a little. Yeah. Yep.
All right. Additional topics for today?
I had something to bring up, if I might.
Go ahead.
Yeah.
Okay. So we had the recent change to increase the ZFS ARC limit on Linux, and there were just a few follow-up items that I had in mind that I'd like to kind of look over with folks on the call here and see if what the opinions are as far as what needs to be investigated further, what should be kind of we could kind of leave aside for now, what should be prioritized. Maybe there's something else that was missed. So let me see if this will share my tab here. So the first thing, can everyone see this? It should say arc pruning.
Yep.
Okay, so the first thing is there's a list, a couple items here. Make that a little bigger. Is that any better?
Yep.
Okay. There's a list, a couple of items here that I was looking into. So some of these have been around for a couple of years and haven't been updated in a while. Let's see, like this first one here, delay next prune if nothing pruned, arc prune, arc evict at 100%. Another one with arc at 100%. The first one there, it looks like the last comment hasn't been for, getting close to 2 years. The third one there, 9966, looks like it says, not seen since 216. And then 14005 perhaps might need to be retested. But since we've had a number of very recent arc pruning change updates, I would just like to get some opinions and thoughts on what would be the best way to look at this. Is there anything specifically that should be investigated, or any other threads I should start pulling on, or can we kind of put these, at a lower priority for now and just see how things shake out over time? What are kind of the thoughts on that? I don't know, Matthew, do you have any thoughts?
I haven't looked at this pruning stuff for many years, so I don't really
Okay.
have any input on it. I think you've, as far as I can tell, you're doing the right thing of finding the existing reports, trying to see if there's actually still issues, with the current code. The arc prune, this is can you remind me how this relates? This is like the ZPL specific like interface with the VFS layer, is that right?
Yeah, I mean, it's the sort of thing that I think the reason it's under consideration here is because it's kind of affected by what can happen in certain cases when ZFS needs to respond to memory pressure on the system. And it goes ahead and, there's the recent work that, a couple of years ago that George and Delphix had done about, making sure that that ARC response curve to the memory pressure calls from the system was actually tracking properly and not having these long lags. And this is just to look into it from the perspective of, okay, now that the ARC has sort of caught up as far as, releasing its buffers back to the system when it needs to, is there anything that pruning needs to do to kind of sort of, keep in sync with that and make sure that it's not hanging on to other things that could potentially, force the system below some watermarks that would, become sort of problematic under a high memory pressure situation. if the system's not freeing up memory fast enough and is getting close to a line where the system might want to start to trigger the killer on Linux.
Right. Right. The arc prune is where the arc is calling back into like the VFS layer and saying, hey, could you please release some holds on my inodes so that then we can release the memory for that, I think.
Yes, you're right. You're right, Matt. So it's generally it was a command tells that it's general purpose, like release my memory, but in practice, both on FreeBSD and Linux, all it does, it only asks OS to drop some inodes to be able, the nodes to be respectively able to drop dnodes, which are stored in some metadata buffers in ARC, debuff cache in ARC. So effectively, it allows to release those references. The code was significantly modified from both how pruning is implemented itself over the years, and in ZFS 2.2, I significantly modified how it is called. Now it's called on two triggers. One trigger is when just number of referenced denodes grows higher than X, some limit, some fraction of memory. And second, when number of unevictable metadata blocks in ARC is higher than some percentage. Like I don't remember exact fraction, but if we see that like half of metadata buffers are unevictable, then we just guessing that they likely been held by the denodes, and then we ask pruning in that case.
Yeah, that makes sense.
I don't know what else can hold buffers for long enough to trigger that mechanism. Potentially, if something else could, then we could try to bring system up to constant pruning after system already gave up everything. But if there is nothing else, then I don't think it should happen. But no matter how I tried, like there could be some buffers which are referenced because they are dirty, but those are limited to a fraction of RAM. There could be some buffers held by another buffers like indirects, but how much indirects we may have in the system, probably not a huge number. Plus we recently reduced ARC indirect block size to 32K, if I remember correctly. So if there are any thoughts, what else can hold the buffer references other than pruning so that we would not over prune the system? I'd like to hear.
Yeah, I think that I do have one other thing in mind to answer your question. But first I wanted to mention, I think there's kind of like two potential problems with arc pruning. One is that it's doing a lot of, like it's burning a lot of CPU for no benefit, which is what a bunch of these bugs are kind of talking about. And I think that's the problem that George was trying to address, several years back. And then the other potential problem is like it's not pruning enough, and we could run out of memory, which is I think the problem that you are concerned with, because you're trying to use more memory. So it's possible that these kind of bugs that you mentioned here might not really be relevant to the problem that you're trying to solve of increasing the arc limit. And then Alexander, you were asking, like, are there other things that could be holding memory that could need some pruning? I actually just was reminded of a bug that we ran into a while back where the debuff cache, so the debuff cache, it basically, like, it could pin data into memory, and the debuff cache is pretty small, so you think like, okay, well, you can't be pinning that much, so it'll be fine. But what we saw was that the debuff, like, basically you could end up pinning leaf like level 0 debuffs, and then that causes like the indirect debuffs to also have to stay in memory, but we weren't counting the memory that those were consuming as like part of the size of the pinned debuff cache. And so like in the degenerate case, you could have like 512-byte leaf blocks and 128K indirect blocks, and you only have 1 out of every 1,000 leaf blocks is in memory, and so you could have this huge inflation. Now that's like kind of a really weird use case that nobody would have in reality, but it might be something worth thinking about at least. I mean, we ran into this when running some like performance tests where we were intentionally trying to like stride our accesses in a way that would kind of maximally like require you to access a lot of indirect blocks. But on real world workloads, like we haven't seen this on it. Our customers haven't run into this that we've noticed in the like 5 years since we saw it in our like strided test. So it may be that's not, it doesn't happen very much in practice with real world workloads.
No, you are valid in that point. Just 3% of debuff cache limit is the size of actual cache for blocks that are not referenced. So referenced blocks are counted out of those 3% on top of it.
Okay.
So
yeah, so the indirect ones are referenced. The 3% could just be the data blocks, and then they're referenced. The indirect blocks have a ref count on them, non-zero ref count, so they're pinned also.
Yeah, so 3% of those are not referenced. Like in case when dnode is opened, it's stored in L0 block. So that L0 block is also not counted as debuff cache. It's not cache. It's actual reference at debuff. So in cache, it's actually what is not referenced. So
right,
idea of pruning is to move blocks from referenced state to unreferenced to actually fall back into the cache and then be evicted from there later under pressure if needed. So question, what else can hold references? You are right that for indirect blocks, I guess on some worst possible case, I can imagine on a random write case when we hold in memory up to like 4 gigabytes of L0 blocks, which in turn hold some amount of L1 blocks. So if you're doing extremely bad random write, you may have quite a lot of indirects, but again, a reduction of L1 size, indirect block size should hopefully help there. And like hopefully in L2, L3, you already get enough of cache hits when same block reference at the same time, not once for each block. But I guess L1 may cause, may create some fraction depending on what is L0 size. But that's probably not something we can do under pressure unless we gonna reduce or dynamically adjust amount of dirty data in Arc. I was actually thinking whether we could try to adapt dirty data max either to pull performance somehow, like to previous transaction commit times or transaction sizes, something like that. Because if somebody using like single drive pool and definitely has like 100 megabytes per second write speed, but just huge amount of RAM in a system, does it really make sense to allow it to consume 4 gigabytes of memory? It's literally like a couple minutes of write traffic. That's
yeah.
Yeah, because the throttling doesn't kick in until 60% of that 4 gigabytes in the first place.
Yeah. On the other side, I have to last forum post recently when a guy asked, let me do all write back I want. Like I have 100 gigabytes of memory, let me write 100 megabytes of data in Arc and then let Arc to back write it later. But another question, how that cooperates with memory pressure?
Yeah, since that's all unevictable.
Yeah.
Yeah, I think something based on timing, because we really want to make sure that those transaction groups are not significantly longer than the default transaction delay, right? It's like if we allow so much that every transaction takes 20 seconds instead of 5, that's probably not great.
Oh yeah, but at least if system was idle and it was dirty data arc was empty, then in 5 seconds of write time without throttling, you can get a lot of data into arc, and then you will commit it much longer than 5 seconds.
Yep.
So the only way to handle that probably collect statistics of previous commit times to see how fast we actually commit, and then try to put another limit. But then another question: do we actually want to commit it early, or will, as that guy requested, do we want to allow put a lot of data in arc to be flushed later? That's potentially other use case, I can guess. Like just if we compare streaming workloads versus Barsty. For Barsty case, I guess taking more into arc could be beneficial.
Right, I think we start a sync once dirty data hits 20% of the max, but that's just the first one. If one's in progress, and we can't start it sooner than that, and it doesn't affect the throttling.
Yeah, interesting area to investigate. But to your point, that's another potential memory pressure source. Dirty data max is limited by default, something like some percent of arc plus 4 gigs, so it should be huge. But
I think
if system under heaviest memory pressure, that may be unevictable, and that may be.
It defaults to 10% of, I don't know if it's system memory or the arc. I think 10% of the arc, but it has a max auto tune of 4 gigs, so it won't go over 4 gigs unless you adjust up from there.
Yeah, that sounds right.
Or the default max is 25%. It's really weird when we have the percentages and the numbers, and sometimes they have different defaults.
Yeah, it would be nice if there was like some kind of more general tuning infrastructure that would make it, so we could have like the right terms, the same terms used everywhere to mean like this value can vary between, X and Y and Z, X and Y absolute numbers and Z percent, and, kind of capture that all in some nice, well-documented way. I'd always get confused about it as well.
So we saw an interesting case recently where, again, I think this is 215, and I'm curious, Alexander, if this is one of the things you've already fixed, where the D node max, which I think is 10% of the arc, is only respected if the arc is overflowing. So if the arc hasn't reached arc max yet, then you can have many more D nodes than that tunable, but it will adjust back down to the tuned limit only once the arc evict thread actually decides it wants to run.
I think you're right. The pruning is called only from arc evict function or thread. I don't think anything else calls it. I was actually talking to Ed a few days ago that maybe it would be nice from OS side just to prune some unused denodes just routinely, but it's a bit out of our scope. I don't know whether we can.
We have a patch we're working on internally for that, and we'll throw that in a pull request then. Because we specifically ran into this case because for the same thing, you also end up with a lot of Z nodes that don't count towards your arc max, and so they don't trigger the reclamation because that's more the ZPL side. And it was, between that and the pinned debuffs and so on, it was causing the killer to go off, even though the arc max was, the arc wasn't shrinking because it was less than the arc max.
But shouldn't the nodes be accounted towards arc? Even if they allocated customly, maybe they should explicitly be accounted then. So that
maybe. But yeah, right now because they're kind of under the control of the VFS layer in the operating system, they don't count as being in the arc. The D node does, but not the Z node. But maybe they should, and that might also help.
No, yeah, V nodes obviously out of our control, but the Z nodes should be ours. No, like a ZPL layer.
Yeah, so we'll look at if we can have those count, or if there's a reason why they don't count currently.
All right, cool.
Okay, so sorry. So I think so there's a couple of things there, but the overall gist I'm getting is not to. I don't think there's a need currently to really delve too deeply into these specific issues. But yeah, I've been kind of taking some notes here, and I want to develop some of the ideas that we had just mentioned. I did have one other side to this, which was the let me get the next slide here. Looking at
Maybe Ed, maybe one
mhm.
sec before you move on.
Mhm.
We saw two other interesting things on a customer machine with many terabytes of RAM. Arc evict wasn't able to keep up because it's single threaded, so it was running at 100%. And this would mean once the arc was full, the read speed of the pool dropped precipitously, like from, I think it was 8 or 12 wide RAID Z1 of NVMe drives, which goes very nice and fast. And then when the arc is full, the evict thread becomes the bottleneck, and the read performance drops by like 80%.
Yeah, you don't need a lot of RAM to hit that. It's not really dependent on RAM speed. It's more dependent on how fast you can add stuff into the arc. So
Yeah.
If your read or write speed is very high, then you need to evict just as much as you're adding once you get full. So if you have small blocks and you can add those blocks rapidly, then you need to evict them rapidly, regardless of how much memory you have.
Yeah.
We've seen this problem
But
as well. I have some thoughts on it, but
okay.
Go ahead and continue.
Many terabytes of 4K records probably also introduces some other scaling issues, but yeah, it was very difficult to it was really hampering performance. And then there's an adjunct to that on the debuff cache, but go ahead.
I just like to add to that I also saw that on my tests too, when it's practically another side of blocks per second limit. One side Ed was fighting with was ability to write number of blocks, the issue writes. Just sync thread was bottlenecked. But once that is fixed, eviction may indeed be another problem, because on my tests, throughput of eviction was slightly higher than issue rate. So it wasn't the biggest bottleneck, but it may be the next bottleneck after we can issue multiple writes same time.
Yeah. If you're doing reads, then you can hit this
Yes.
more easily. It's more like the more CPUs you have, the reads scales pretty well, but the eviction is still single threaded. So that becomes the bottleneck. I think that it would not be too hard to make the eviction multi-threaded now that we have multiple, the sharded lists, the multi-list thing. I think they should be possible to like dispatch one like eviction job for each of those each of the sublists of the multi-list, and therefore get more CPUs involved with it.
Yeah, it should work. Just one CPU should probably do forecasts how much should be evicted in general, exactly. And then create several subtasks to do each job.
Yeah, like the main one sees, oh, we need to evict like a gigabyte. Okay, well, I have 8 sublists, so a gigabyte divided by 8, that's how much each of these sublists are going to evict, and kick off tasks to do them.
Yeah, that's should be doable now. Meanwhile, just for some benchmarks, I'm more often using primary cache equal metadata. Since now since I fixed it again in 2.2, it can do both prefetches, it can do properly sub-block reads, sequential sub-block reads. They are still cached in debuff cache. So with those fixes, it's more usable. And in mentioned case of NVMe pool, pretty wide, maybe just you don't need cache data at all. Just say primary cache metadata and call it a day.
Yeah, sadly they're still on 2.15, so they don't have that yet. But yes, thank you very much for that fix. It's quite amazing how well it helps. The other thing we saw was the debuff evict has a similar problem. It's a bit smarter in that every reader can, if the debuff evict thread isn't keeping up, every reader gets assigned to do some debuff evicting before
Yeah.
they get to do their write. But all of that, it has like a loop that calls debuff evict 1, which starts at the bottom of the list, the multi-list, and walks up until it finds something and get the lock on, then evicts it, then exits, and then starts at the bottom of the list again.
Yeah,
And
so
it's
you can
like
end up
maybe
skipping
we could
over a lot of debuffs. You end up like
the
skipping
same
over
ones
the end,
over
right?
and over and over.
Yeah.
And it's like, could we maybe teach it to like keep evicting till you evicted 100 and then loop back and maybe walk over the same ones again, instead of just I'm going to brute force pound on the very end of this list over and over and over and over and over again.
Yeah, I mean, it seems like at a minimum, just doing it in some like batch
Size, yeah.
size would help a bunch, even if it's not really an optimal solution.
Mhm.
That might be easy and good enough. Like if you're going to evict, just like minimum, evict at least 100 things
Yep.
before exiting the loop.
Yeah, so that we don't start at the end of the list again.
Yeah, that's a good idea.
And a
You
small
see
enough
a
chunk
lock?
that we're not holding the lock for very long.
I was going to just say that. Yeah, do you see a lock scaling issue there? Because I, I was wondering what that would do.
Yeah, because it's trilocking every one of the objects that walks up, but I think if we just make sure we're iterating over the sublists properly, then that should solve the lock scaling. But we might need to fiddle a little bit to make sure that, if the sublist it picks to work on is already locked by somebody else, just pick a different one and do your work on that one instead of waiting for exactly what Ed was saying there.
No, but have you actually seen a contention of those locks? Is it a sublist lock or it's hash lock? Which exactly are you? I thought you're talking about hash table, hash lock of ARC. But what chance of getting conflict there? ARC is huge, a lot of locks.
Yeah, we've not looked into it that far, just that the debuff thread could probably make more efficient use of that 100% CPU time it's hogging when it's trying to evict by not walking over the same, the list of items at the end of the sublist over and over and over again.
And just a quick question for my understanding. I want to make sure that this is the same set of sublists that I was just looking at as far as like the sync thread is concerned, right? This is not some other set of sublists, or am I misunderstanding that?
This set of sublist is the debuff cache.
Okay.
Yeah, and then also the ARC cache has its separate multi-list that it's evicting out of. Or a couple of them, but yeah.
Interesting. Okay, cool. So the other side of this that I'm looking at, particularly with Linux, was as far as there's some additional items on there that say things along the level of, better integration with system page cache. And looking at a couple of these, I'll skip the first one for now, but looking at 13178 and 10516, the actual tickets themselves look pretty general, right? Like when it says system page cache here, I think they're talking about, both systems, FreeBSD and Linux. So my question on these two, just like I said, they seem very general, is if these could be even considered feasible at this point, or do we need to get more specific on what the ask is in these cases? So that's those there. Then this last one here with the init on alloc, that I think is something that we're just probably going to have to deal with, right? We're going to have to probably live with that. Some of the solutions are just to disable it with a boot time parameter. But because Linux at least sees it partly as a security approach, right? Because they don't want to leak reallocated data in reallocated kernel buffers to potentially other uses. They're probably going to, keep that. So does that also seem like an area where there's any ideas that we need to address? And I'm just kind of touching on these right now, just to kind of sort of help kind of the thought process along about what needs to be focused. Let's see. Oh, the debuff cache eviction, that probably should go on the previous slide. But then kind of getting back to this first one here, it talks about accounting some of the the available ARC data in the Linux meminfo stats basically. And the motivation behind this is because there are some user space tools like OND and others that are coming up. What are trying to do is sort of predict the system memory usage and kind of adjust things so that it reduces the impact of the OOM when the memory pressure starts climbing. So this is something that I'm looking at right now, and I think the key thing here is that this is going to need to figure out some kind of kernel API that allows the file system to do that, and it's going to probably have to do it in a license-friendly sort of manner. So I'm not sure what the situation is there, but I'm just working on that one to understand it as well. But I'm just curious if anybody knows of any other particular system page cache related sort of requirements or work that's going on, perhaps if any of this is being currently investigated. I don't want to be replicating someone else's effort or anything like that.
On the second one there, we've been playing with how to loan buffers from the ARC to the system page cache on FreeBSD to make send file work properly on ZFS.
Okay.
Or like KTLS, or being like, hey, here's the zero copy this data from the file and encrypt it and send it out the NIC or whatever. So we've been playing with that a little bit, but that's improving the interaction between them and avoiding copying, but it isn't really full integration.
Yeah, I mean, some of this is really just like double buffering. My impression
this one
that
avoids the double buffering by being able to loan the ARC buffer to the system with the system's promises that it won't modify it on you.
Okay. Because another side of that too is how do we deal with things like compressed data pages in the ARC, I guess.
Right. I think we end up having to loan the debuff version of it after it's been decompressed.
Okay.
Because you can't loan out a compressed page to the kernel because it will be very confused.
Yep.
And I think the same with currently we linearize it as part of the debuff version as well to avoid the kernel being like, what's this weird scatter gather thing you're doing here?
So, I mean, one of the things that kind of occurred to me just thinking about this was how something like that could be done kind of in sort of an OS neutral architecture, right? So that we could actually implement these things in according to a particular API and then sign up, okay, this will work on FreeBSD, this will work on Linux. And I really am not sure about the feasibility of that, but that sounds like something that we could, at least start kicking around or discussing.
What we have so far is mostly modeled after a PS ARC or whatever from Solaris for ZFS specifically for doing zero copy. But that was did weird things with having an extended version of a UIO that had a private pointer back so that the ARC could track that it had been a loaned out buffer and so on.
Okay. Yeah, it was kind of sort of doing, it sounds like it's doing these backstage, backstage manipulations.
Yes.
Okay.
Most of that code got ripped out a while ago. But yeah. Okay. It's mostly just having a way for ZFS to know or to identify the pages having come from ZFS and make sure that it got handed back and dealt with.
Did that involve any modifications to system code, or was it all within the ZFS layers were able to handle
I
that.
think it was mostly within the ZFS layers, but it worked by doing evil things like when ZFS allocates the UIO, it allocated it bigger to have the extra fields, but then you like cast it back to a normal UIO and it goes through the system API.
Okay.
And
Okay.
it was quite evil.
Interesting.
For the init on alloc, I don't know if there's much we could do other than like caching our allocations and not giving them back and allocating them fresh to avoid the cost of init on alloc beyond the first one.
But even if we did that, wouldn't we have the same security issue, at least potentially? Because yeah.
No, like as I've told in a private conversation, I would trust us more since we have pretty limited number of ways of working with Arc, with debuff cache, and other places where ZFS does allocation. I would inherently allow it for things we use for data transfer, while it may be more complicated for management structures, for some headers and who knows what. But when we do like allocation, like for 16 megabyte for data buffer, we don't want to be overwriting 16 megabyte just because.
Yeah, it's
if
pretty
we are
easy to
expecting,
look at those few code paths and see like, oh, we allocate it, and then we like copy over top of it the entire buffer size. You know, in those cases, you can be pretty clear, and you could, if there was some, you know, allocate without zeroing API, it would be reasonable to use it in those few cases, few code paths that pertain to most of the memory being used.
yeah, as I've also told in private conversation, it would be good to investigate, is there any way to disable that functionality on per allocation basis? Like, there are explicitly arguments for M0, like on FreeBSD at least. You may specify when you want it to be zeroed and you don't want it to be zeroed. If you don't want it to be zeroed, then you are supposedly should handle it by yourself to initialize it. And for OS, practically ignore your request to not zero but still zero. It's stupid. Like you are by definition saying I am not trustworthy. I am bad programmer. I'm not just eat my memory bandwidth, and that's not the way I'm ready to accept it.
Yeah, we need to add a new flag that's like, no, really, really don't zero it.
Mm-hmm. I promise I will overwrite all of the data before I use this.
Yes. Secret handshake.
Okay. So yeah, thanks, because those are some good thoughts, I think. Anyway, I just, like I said, wanted to kind of sort of raise this and see if there were any particular directions to derive from this as far as either now or later. Would this be the sort of thing that it would be beneficial to, like, you know, bring up perhaps at the next meeting and see what kind of direction and progress can be done on these? How do folks feel about something like that?
Yeah, I mean, if you work on this, we'd love to hear about it at the next meeting.
Okay.
For sure.
My homework assignment. Cool. That was all I had. Thanks.
Yeah, and the arc eviction CPU usage stuff is kind of on my radar. So if anybody is interested in working on that, I'd be happy to help out. Hey, Alan. All right. Yep. Yeah. Feel free to ping me offline and we can coordinate.
Great.
Cool. Any last topics for today? All right, then I'll see you all next month. Oh, next month, I have a conflict for this meeting. Alan, are you around? Could you lead it?
Yep, I can.
Okay, cool. It'll 4 weeks from today. It's first week of December, December 5th. It'll be at the later 1 p.m. time. See folks. Well, I won't be there, but enjoy the next meeting. Yeah.
Actually, I won't make that one either, but
Well, if you
Thanks.
want to just leave notes in the doc, Ed, then we can maybe still discuss some of your topics anyway.
oh, all right, perfect. Thank you.
Sounds good. Bye.